So if you take a database where we have a web page with a phone contact and a submit button, submit is nothing but like an insert query which runs at the backend. So this inserts the data. Let's suppose this data is stored in some pod P1, right? Let's suppose there is another button to view the data or edit the data. Let's say this request goes to another pod P2. It wouldn't work, right? Because the data is stored in the first pod and we are trying to, the view request went to the pod 2. So this doesn't work. Means here what is happening? All the pods are not the replicas, means each pod is unique. Data is stored in some pod, you're trying to view in some other pod, it wouldn't work. So when pods are not, the replicas are not same, means here every pod is unique, right? So how to handle this? What happens if we try to store such applications with a deployment object? Deployment object is it will have the replicas, right? It could be any number and each replica is same. So in that case, in submit queries, insert queries may go to P1, some view queries may go to P2, and this is how it would work. And if this keep on continuing, like data inconsistency arises, right? So how to handle such applications? Such applications where the action is dependent on the previous state, we should be storing in something called stateful sets. In stateful sets, every pod would be unique. P1 is unique. Every pod will have a unique identifier starting from index 0, right? That's a pod 1, means first replica, second replica with index number. That's called its identity identifier added to identify each pod. And the first pod or the main pod, this is called the master pod, where all the read write access goes, means this will have all the read write, means all the submit, all the read requests would be going here. And every other pod would be a copy of master. Copy of master means, yes, it will have all the data present in master. And this would take only the read request, not read write request. It will take only the read request. So what happens? All the write, all the insert operations, edit operations are stored in the P1. And every other pod is copying data from P1. So obviously they will have the same data, but all other pods would take only read request. Only the first pod would be eligible to take write request. This helps in controlling the data inconsistency, right? So this is how stateful sets work. Means when you create stateful sets, yes, if you say two replicas would be created, but each replica is unique. Each is having its own identity. So also in stateful sets, each pod would be created in a particular order. First 0th pod, then the next pod. And they'll be deleted. If you want to destroy, they'll be deleted in the reverse order and so on. Right, that's how the stateful sets work. So here Java application or the front end, the web app, PHP, these are all stateless. A particular action is not dependent on the previous, so you could deploy it through deployment object. But DB, you should deploy it through stateful set. That's a right method. So we can go ahead and delete this deployment object for DB and create a stateful set. Let us see doing that. First, let's see what are all the deployments we have. Get deploying. Deployment 1, deployment 2. Get service. 30,001. So data is being stored here. But now I say this deployment 2 should not be used, right? Like we should deploy it through stateful set. First, let's see the pods. So we have one pod. Let me just delete this deployment completely. Delete deploy 2. Now we'll create it through stateful set. But before that, get PV, we have PV, PVC. Yeah. So PV is fine. MySQL one we have. It's attached to MySQL PVC. Here what happens is we don't need to create PVC this way. We'll create PVC through stateful set itself. So let me clear off this PVC as well. Delete PVC, test PVC. Oh, sorry, it's MySQL PVC. Now let's create the PV and PVC. I cleared off everything so that I would give a different name to this, and it would in turn attach to the PVC, which will be created through stateful set template. So let me create the PV. Also here I'm going to create two PVs so that, see, when pods are unique, it should have a unique PV as well, isn't it? Because they're having different data. So this should be stored by, I mean, this should be consumed by first pod, this would be consumed by the second pod. As each pod is unique, their data storage should be unique. Let me create this first. Apply -F. Okay, PVs are created. MySQL stateful set. Now let me create stateful set. It is similar to the deployment object. Few changes would be there. Let me show you. There were additional spaces. Okay. So stateful set, kind is stateful set, metadata, name, deploy to, or else you may give any name of your choice, and then labels. Labels, if you see, I'm giving label as app MySQL. And then comes specifications. Specifications and the replicas. I'm starting two replicas. Same like deployment object. It has got some selector labels which will be there in this stateful set, and then the service name. Template. Template is, you know, right? You have a template or the format of how pod should look like. So this is the metadata of the pod. So it's going to have a label called app spec, specifications. Some termination in seconds. When you terminate, it would use this. And the key is Docker key. We have the secret, which is Docker key. And then the containers, actual configurations of the name of the container, the image used, image pull policy. And then the ports. Ports are like which port your container, database is running, but we are not exposing it. Setting environment variables. We have seen this, right? Everything is same. Secret key reference. Volume mounts. Name of the volume. And then see here, volume claim templates. This is important. Actually, volume claim templates is as many number of pods you have, it would be creating those many number of PVCs. That is the meaning of it. Volume claim templates. It's a PVC we are creating earlier manually, right? Now we have template for PVC also. As many number of replicas you have, those many claim templates will be created. See, read, write. Earlier we used to give this separately, but now you have all of that here. Storage class, access modes, read, write, resources, either the size of the resources, everything you have here. Is this much clear, everyone? Any questions? Now, let's say you create two replicas. Two PVC will be created using this claim template. Right? So let me save this. Also, let me delete the earlier service. Nice. So stateful set, get stateful set. This is our interest. Get pods. Here, if you see, this is the identifier I'm saying, unique identifier, sticky identity added as a prefix. First, this one is started. If you see this is running, this is still in the pending state. By now, yes, both are ready. First, they'll be created in this order. This is the first one. This is the master pod and this is the next one. So we did not create PV if you remember, but PVCs might be PVCs we did not create. So see as many number of pods you have. Do you see that with this name prefix? This is for 0th one and each got attached to this PVs. That's how you don't need to create them separately. This is how you create them. Is this much clear, everyone? Any questions?
Yeah, I got confused with the PVs and stateful sets. PVs are according to the
Have you
knowledge I
gone
have,
through
they're
the
for storage. They're for storage and stateful sets. I don't understand.
Have you gone through the recording last class? Have you done the hands-on PVCs?
I came up to PV only, not PVC, not claims.
PV and claims work together, right? You can't create
Yeah,
PV separately without PVC. Both work
okay.
together. We don't
Yeah,
have
they're the storage for a particular pod or a container because a pod stores its data while working in a persistent storage called PV. But the stateful set, I'm confused.
stateful set help you to have unique pods. Like you don't have unique pods in deployment. In deployment, you have all the pods are same. They're all replicas.
Replicas, only replicas.
Hmm. Here, that's not the case. That is a difference.
So through replica sets deployment, you are creating unique pods.
Yeah.
So to those unique pods, you are attaching the storage
Yeah.
device, whatever it is.
Yes.
Okay, okay, thank you.
Deployment stateful set are almost same. The difference is in deployment, each replica is same. Each
Yeah,
replica,
I understand. I understand that. See, the replica deployment, and the replica set. In deployment, you will create all similar pods. Here, you will create unique pods.
yes. So in replica, in deployment, we'll have a same object. Like we have all the replicas are same, right? It could be created in the random order and they could be destroyed randomly. Request may go to any replica, right? That's how they're all, as the name says, they're all replicas. Here also they're replicas with configuration wise, they're replicas. But what happens here is like you have each pod is unique because the write operations goes to the master pod and the read operations goes to the rest of the pods, so that they are unique. It's not that to avoid data inconsistency for all stateful applications, we should use this kind of stateful sets.
How do you segregate master pod and worker pods here?
We don't segregate. Whenever you create it, that's how it works. Like it will create the first pod with,
Through stateful sets deployment, automatically pods are
yeah,
distinguished like master and
yeah.
workers.
Yes. And now data is stored, data is stored again here, you can see. And this is how stateful sets work. Stateful sets are for advanced concept. And for stateful sets, yes, the general logic is master pod will have the all the data, write, read, write, and the other pods will have the read operations. But there were so many applications, standard applications, like you have SQL, you have so many stateful applications like Kafka, message queue service, or any message queue services, database applications, and so on are stateful, right? And also for each application, this logic might be different, should be different. It's not that always master pod should take read write. So each application may have their own logic. So how do we handle this logic? Means there's a lot of manual handhold needed to deploy stateful applications. Application experts has to be involved, isn't it? Because I don't know how SQL works. I'm not a DB admin, or else I'm not a Kafka like expertise to know how those pods work, how the application should be set, how data will be stored, how I can set the logic. So this is the general logic, but each application will have its own logic to be set, and there the product experts handhold is needed. So a lot of manual work, lot of handhold work is needed for stateful applications. So to avoid this, they developed something like SDKs, development kits where the logic could be set and all. But for us to make the things clear, for such stateful applications, instead of we working with all the logic, we can use something called Helm charts. Helm chart is a separate concept. There are Helm charts where you can deploy these stateful sets automatically. We'll come to that part, but just understand these stateful sets needs a lot of manual effort and so on, which would be handled better through Helm charts. Instead of we deploying manually, we can use Helm charts for this. What are Helm charts and all we'll learn. Then you can connect to what I'm saying here. So finally, PHPDB's application, PHPDB application is deployed in the right way using stateful sets, and they are communicating. Okay.
One question.
Yes.
Yeah, if we creating the PVC, the PV also will automatically will create.
No, PV we have to create. We created PVs, if you remember. I created this.
Okay.
Is it necessary for us to create PV or system creates PVs?
We have to create PV. We created PV. This is the PV manifest file.
Okay.
PVC will be created. See, what is created automatically, what is not is very obvious. If you see the manifest file, here you have claim templates, not volume templates. These are PVC templates. So every
Yeah.
PVC, as many number of pods, you have 2 pods means it using this template, it will create those PVCs. Where is PV? Is PV anywhere automated here? Any configuration for PV? PV
No.
will not be created. We have to create the PV. We have a separate manifest file. This is where it is PV coming from. If 3 replicas, we have to create 1 more PV. In reality, there will be so many PVs created when the cluster is created. That is taken care by Kubernetes admin. So that whenever pods are created, they could be attached to those PVs. If PV is not there, you straight away create PVC, or PVC will be hanging straight. It cannot be bound. like this, and hence your pod will also be hanging in the pending state. PV, PVC. See, it's bound. If you don't have PV, it will be in pending state, searching for PV. Your pod would be in pending state because it can't find the PVC. Are we good?
Yes, please.
Okay. So now, okay, we have seen creating so many objects, and if you see, you can do get all so that it will show all the objects. For this PHP we have created one deployment object, stateful set, 2 services, total 4, and then is that it? Secrets, right? 2 secrets. Secrets will not be shown with get all. Okay, so this is one, deployment is 1, this is 2, 3, 4, 5, 5, 6. Okay, we did not use config map, so 5, 5 and 6 because both of them we use. 5, 6, and what else we created? Ingress, right? 7, or else if we haven't used ingress, 6. Anything else we use? PV. PV 7, PVC 8. So almost 8 or 9 objects we have created manually to deploy this application and finally see that it's working, right? So it would take some time. Even for me, for the first time when create these objects, it took a lot of time. I should get the manifest from files from Kubernetes.io. I have to modify it accordingly, right? I have to plan and design what are all the objects I need to have, 2 secrets, config maps, or I need to design all of this and create them from the scratch, which would take some time. Even it took me some time, right? If it's not working again, I have to troubleshoot and fix it. Similarly, to deploy any enterprise application, you may need to create so many objects from scratch, right? So instead of doing this, if it is any standard application like SQL you want to deploy, Nginx you want to deploy, or Tomcat you want to deploy, or you want to deploy some Kafka service or RabbitMQ, or if you want to deploy some JMeter services, whatever. Like if you want to deploy anything in your cluster, maybe any monitoring tool or log analysis tool like Splunk, you want to collect the logs and analyze them through Splunk or monitor the cluster. You have to create these many objects from the scratch. Instead of that, you can use something called Helm charts. What are Helm charts? Helm charts are nothing but Helm chart. Okay, Helm is like a package manager for Kubernetes. First, let's talk about Helm. Helm is a package manager for Kubernetes. What is package manager? Like you have yum package manager with which you install Tomcat, everything, right? Yum install. Similarly, Helm is like a package manager for Kubernetes with which you can install your applications. How do you do that? With something called Helm chart. What is a Helm chart? Helm chart is nothing but a bundle of manifest files. Right, there were so many Helm charts already available on the Helm repositories, some storage place. You can download the Helm chart from there and use it. Like for all standard applications, like I mentioned some time back, you have Helm charts. You can just download and use that Helm chart instead of you writing those manifest files from the scratch. Particularly like stateful sets, I don't need to write the logic. Like I said, each application may need its own logic. So all of that would be taken care by this Helm chart, coming with all the customization. And we can use it. There are already so many Helm charts which we can use. So for that, first Helm should be installed on your cluster. See, there is no Helm. First install Helm on your cluster. Then you can install some Helm chart. So let me show you that. If you want to refer, you have again official documentation, helm.sh. You have all the documentation, charts, everything. See topics, how is it organized, how to do chart, everything you have. And there are so many Helm charts, Helm repositories available. See, you can search artifacthub.io. You can search for whatever chart you need. See, some examples, PHP chart, ingress, or else flux CD, counter. You can search whatever you need. Let's say I need a Helm chart for Nginx. I'm searching for one what we know, like Nginx. See, these are all different Helm charts. What each Helm chart has, what are all the configurations it has, it would be explained here. See, this is how you add the repository and install the Helm chart. Uninstalling the Helm chart. What are all the parameters? See, whenever you install a Helm chart, you will have, okay, I'll come to this part later. First, let me install Helm here. Like any software, you can download the tar file and install it. Actually, you should install this Helm not on the cluster, but from the place where you install those charts on the cluster. Means like I told you in the beginning, right? This is my master node and worker node. It's not that you go on to master and do all the kubectl commands. Outside the cluster means from your laptop or some jump server, that's where you run all these commands. So that's where you have to install kubectl and that's where you have to install Helm. Because I'm anyway using master as a like a connection server or directly I'm using master, I'm installing here. I'll show you connecting from other machine as well. So downloaded the star file, extract the star file. Move the star file, okay. Done. So Helm is installed. I'll share, you can install it on Windows and also connect from there. I'll share it, but that's okay. Okay, Helm is installed now. You can see Helm repo ls means what are all the Helm repositories you have. No repositories to show. You can add the repositories. Which repositories? See here. If you want to install Nginx, they were available in this URL. Charts, Bitnami charts. You have to add it. Then you can search the repo. For example, let me show you. I'll not install Nginx, but as an example, okay, I have Helm repository here. Add that Bitnami chart. It's a huge repo. It is taking some time. And one more thing is to use this Helm, you definitely need t2.medium instances, which are not free. So how do you do that? I'll show you another option. See, it's taking some time. Do you see that? Because size concern. Leave that because it just stays there hanging and pending. I'll show you another option. One option is, please listen here carefully. One option is you may create your cluster or add worker nodes with the T2 medium instances. Or else then other option is we can have something called Minikube cluster. Have you heard about Minikube? Minikube is a single node cluster, but it gives you a kind of Kubernetes cluster yes, a simulated environment so that you can do hands-on. This Minikube, you can again create on any EC2 instance or in your Windows machine or your laptop, a Mac machine, anywhere. So I'm going to install this Minikube on my laptop. Means a Kubernetes cluster, a single node Kubernetes cluster for your learning purpose. This is the best way you can do, right? So let me create a mini. You may take some EC2 instance and also you can install that Minikube. Okay, but I'll install, see, it just stays here. So let's go to Minikube. How do you install Minikube? There is official documentation again. This is for hands-on. It will be very helpful for learning purpose. See here, Minikube can be installed on multiple operating systems. If you want to install on another EC2, yes, you go for it. Mac, here. Windows, yes. So go here and install it. Curl, like download this and move it. It will install. It's a command Minikube start. But before that, Docker should be started. That's the condition. So I have already Minikube installed. Let me start it with Minikube start. Am I making sense? Okay. minikube start. It will fail because first Docker should be started. See, exiting is Docker daemon running. How do you start Docker on Mac or Windows? Anyone? We have seen that. As far as I remember, we have seen that. We have installed, I have shown you Docker on Mac. How do we start Docker? How is Docker installed on Mac or Windows?
Docker desktop.
Exactly, Docker desktop. So start Docker desktop. Where is my Docker desktop? You can go to the applications if it is Mac. If it is Windows, go to the start menu and install it. Okay, this will start Docker desktop. So once it is started, anyway, we'll use CLI. Because it needs Docker, it will start this as a pod. Sorry, as a container. So now let us start Minikube. See, pulling base image. Docker container for Minikube. Your Minikube will be running as a container. Yes, Minikube is started. How do you see that? kubectl, by the way, you should install kubectl as well. Like I told you, right? Either it is a on-prem cluster or cluster on AWS, wherever it is, you will connect it with kubectl. So this also should be installed. Get nodes. If you see only one node. That's what is single node cluster. Control plane. But you can just use it for our learning. It just works like cluster. Get pod. See, already I have some pods if you see. Do you see that? Okay, let me do get all. Let me clean up this. Let me clean up. Delete. Deploy.
20 रुपए की स्क्रीन ऐसी लगवाई 2 दिन भी ना चली.
Please keep muted everyone. Nginx. PHP. And get deploy. See, same like every commands are same, concepts are same. I'm just cleaning up some objects. Delete service, MySQL. Delete Nginx. Delete PHP. Okay, and one more thing is get namespace. Okay, all right. Okay, fine. Now let's see, Helm is installed here. Now let me check Helm repo ls. Like I added a chart here, right? But it is still in pending state due to insufficient resources. See, this is the case here. Do you see that? This is on EC2 instance master. But now in my Mac, right? Once you run that command, your repo will be added like this. Now continue from here. What I did, I added a Prometheus one. Just a second. Okay. By the way, kubectl get ns. I have created a separate namespace here. Do you see? How do you create a namespace? Kubectl create ns. Let's say test namespace so that you install your application here. Create ns will create a namespace. See here. You can install your application here. Here, if you see Helm ls, Helm repo ls, I have the repo added. And if you want to search any particular chart, this repository can have multiple charts. So how do you search it? Helm search repo, something related to Prometheus. I want to install something for Prometheus. See, these are all the different charts. Cube, Prometheus stack, chart version, app version, description. So many Prometheus charts are there. Prometheus, Windows Exporter, and so on. So I would need this one, which can monitor Kubernetes, resources. So this is the chart I want. Chart is nothing but group of manifest files for stateful set, deployment, replica, service, all of that will be there. And every object means it would be like, let me give you some idea of Helm chart first. You imagine Helm chart like a bundle, right? Imagine it like a bundle of charts. What are all the charts you have? It will have a certain structure as well. Pen, I'm grabbing the pen. Pen is not. So, sorry. Okay. So whenever you create any, you can also create your own Helm chart. So Helm chart will have a certain format, means certain directory structure, like templates. Templates means it will have all the deployment object, service object, ingress object, all of them will be there. But it's like a format, or it will have all the variables. Just the variables means, let's say deployment name will be a variable, service name will be a variable, port number will be a variable. Means those are parameterized templates, where you can pass those parameters. How do you pass the parameters? There will be a file called values.yml from where you send the values, right? So these values will be replaced. You may use this Helm chart. You can create your own Helm chart as well. Let's say you have a microservice application, and let's say you have 8 services. All of them are same. You have to create 8 deployment object and 8 service objects. So you mean to create 8 plus 8, 16 manifest files. Instead of that, what we will do, we will create only one service object and one manifest file for each, and we'll pass those values. Means they will be parameterized and we pass those values. So Helm chart is nothing but it's like a template or a format which you can use to deploy multiple microservices as well. Right? There'll be a values file from which you pass the actual values. We'll talk about the creation of this Helm chart also in detail. Just understand it will have all the templates and values will be passed through a file called values.yml, right? So similarly here also, this Helm chart is already having all the objects. We need to send the values. So what are all the values? You can customize those values. If you see here, these are all the right. If you want to see any values of any Helm chart, I'll show you the chart structure in the next class. Today, I'll show you installing the standard one. Show values and whatever chart you want. Okay, let me first grab this. Okay, this is the one we want. Let me copy this. This is the repo name and this is the chart name. So copy this and then Helm show values of this particular chart. See, it will show you like this. If you go through each one, you can understand. It will ask for, because it's a huge configurations, there were so many values shown here. It begins from here. See, app name, app equal to. You can pass every minute value, default values, all the default configurations. These are all the parameters that are defined. Annotations, labels, service type, whether it is cluster IP or node port, what service type you want, you can. If you don't pass the value, it will have the default values and it could install. But if you want, you could also customize the chart. As of now, I'm installing the chart using the command helm install, some name to your installation, let's say Prometheus, and then the chart name and which namespace you have to install. This is the command. Helm install, some name for your installer, chart name, and in which namespace you want. And I'm not passing any values. It will install with the default values. I'm canceling it because it's already installed. You can see with Helm LS. Helm LS, you are seeing only SQL, Nginx and all. You check with the namespace, or -a means it will show charts in all the namespaces. See, it's showing here. Prometheus is already installed. Okay, how do you see all the objects? Get all in this namespace. If you don't use namespace, it will show in the default namespace. See, already so many pods are involved, installed, services, daemon sets, deployments, everything, stateful sets, right? Imagine how much time and effort it would take for you to configure all of this, isn't it? Definitely it would take some time. And out of all of this, if you notice, all of them will be installed as a cluster IP. Let me uninstall and reinstall this so that you will see from the beginning. 1 second. How do you uninstall? Helm uninstall. Chart name or else installation name MySQL. Uninstalled, it says. Let's see the list. Yes, it's gone. So uninstall Nginx. Uninstall PHP. Uninstall Prometheus. -n namespace because it's not in the default. Okay, done. Now if you see Helm ls -a, everything is done. Now let me reinstall it. Helm install Prometheus and the chart name and the namespace name. Yes, Alan, you can install Minikube on EC2. Yes, you need to have Docker installed. Just on if it is EC2, minstall Docker will do. See, it has installed. You can see here the status and installation. Now, let's see, get all -n Prometheus. Now, these are the fresh objects just now being created. Do you see all of that? Yes, right? All the objects you can see very clearly. And if you see the service, and by the way, I have installed Prometheus stack, means Prometheus along with Grafana is installed. And this is the Grafana service. And Prometheus service runs on 9090. This is the one. Prometheus and Grafana both has the UI. I want to access it from the browser. Is it possible? How to access this from the browser? They are of cluster IP. Can I access them from the browser? This one.
No.
And this one.
No.
So what should I do if I want to access from the browser?
Load balance.
First, let me make this node port. It should be node port. Actually, it should be load balancer via ingress. Ingress should be load balancer. This should be cluster IP, but we don't have ingress here. I would like to just change this to node port so that I can show you. We can see that on the UI. So just let me change this. Okay, let me copy this service first. Just a second. I installed an incorrect chart, I think. Okay. Okay, let me edit this service. You may edit it this way. kubectl edit the service name and -n Prometheus. Okay, if you just scroll down, this is the service object and it should be of type cluster IP. So change this here as node port. Save it. It says it is edited. Let's see. Yes, do you see that? It got changed this way. And also let me change this service. Let's copy this. kubectl edit namespace Prometheus. Now let's come to the last line where the type is defined as cluster IP. Node port. Now, yes, this is also changed. It's on 31612. But on which node you will hit? Do we have multiple nodes here? It's a single node cluster, single node running on my laptop, right? So you can do port forwarding, port forward this service. Which service? Let's say first this Grafana, Prometheus Grafana service. And the port number. What is the port number? It is forwarded to, if you see, 31612. 31612. And the actual port is 80 on the container. And the namespace Prometheus. Right? So let us do this. Right? You should not close this window. It has forwarded internally. It's port 3000. I would like to forward the other service also, which is this one. This is the additional step you have to do to access it on the current node. Let me open one more tab and forward this also. kubectl port forward this service. And the port number is 32455. 32455. And it's 9090 of the container in this namespace. Prometheus. So let us hit this 32455 on the local host. Localhost is my laptop. Localhost 32455. 32455. See, this is the Prometheus UI. How to work with this? We did not learn Prometheus yet. Okay, just we have installed it. And then this is localhost colon. What is the other port for Grafana? It is 31612. 31612. See, this is for Grafana. And the Grafana password is admin and from operator. How it works, it is all different story. But using Helm chart, I have installed them on the cluster. If I haven't used Helm chart, do you know like all the effort we need to put, right? So that is the advantage of Helm charts. Here I am just showing you installing the chart. How it works and all we'll see. We have to learn Prometheus, but I'll just show you an overview of what it is monitoring. But is this much clear, everyone, what a Helm chart does? We can create our own Helm charts as well. We will learn that also. Okay. So is this much clear, everyone? Are we good?
Yes, President.
Now we have to learn Prometheus to understand how it monitors, how you have to see resources and all. We did not learn Prometheus yet, but just I'll show you quickly. As you install this chart comes with all the custom configuration. And see here, do you remember API server? All the API server details, container details, core DNS used in Kubernetes, HCD details. Do you remember HCD? All these components it's monitoring, right? Instant node, kube API server, kube config maps, default config maps, daemon sets, deployments. It's monitoring all of that. I'll just show you a small thing. Cube node created. We have only one node, right? It's a mini cube cluster. So it was showing these details for the node. So you can search any metric here. Go to the metric explorer, search some metric. You can search any metrics here, like volumes, work queues, reloader, reconstruct, Prometheus, all of that you can see here. Even Prometheus details also it's monitoring, right? Prometheus is the monitoring tool. Grafana is a visualization tool because Prometheus has got a very simple minimalistic UI. But to create custom dashboards, to create more sophisticated dashboards, we have Grafana. It's a visualization tool. Grafana is not monitoring tool, remember. Okay, but here the whole point is we'll learn Prometheus later. Installing it with the Helm is the whole point. Likewise, you can install Kubernetes dashboard also. Do you remember in the beginning I told you Kubernetes has got the CLI as UI, but UI is very rarely used. We don't rely or we don't use CLI for UI for Kubernetes. We always use CLI. But in case if you want to check, yes, we can configure that dashboard. Shall we install that dashboard? Let us install that dashboard. You may install manually or you can install it through Helm chart. Of course, I'm installing it through Helm chart now. Let's go ahead. Helm repo ls. We have the dashboard in some other repository. So let me add that repo. You have to search on the repositories and see that. See, Kubernetes dashboard is added. Now, if you see the repo ls, you have one more. Here is the dashboard. Now you can install this. Helm install. This name, I'm just giving name to my installer. This could be any name. I'm giving the same name and the chart name. This is the chart name. Of course. Okay, first let me show you the chart name here. Helm repo. Search this repository for the chart. Charts are present in the repository. So search for the chart in this repository. This is a repository name. Dashboard. Helm repo search. It is Helm search repo. Yeah. Okay. Only one chart. This is available. Now you can install it. Helm install. Some name. I'm giving the name as dashboard. It's your own name, user defined name, and then repository name and the chart name. Right. And if you don't provide the namespace, it will create in the default, which is fine. Or if you want, you can create in the namespace. I'm just creating in the default namespace. See, it says it is installed. You can see get all in the default. You will see what are all the objects that are installed. See, these are all Kubernetes dashboard is again installed as a pod. So these are the deployments, services, replicas that created. No stateful set created here. Right now, if you want, edit this service. Where is this? All of them are this one. Actually, the service is Kubernetes dashboard. Dashboard web, this one. So let me edit this. I don't see this is the right one. It is on 8000 port. Okay, let me try. kubectl, edit the service. Cluster IP, let's make it as node port. Right, this is node port. Let me try out. kubectl port forward this service and the port 31428 8000. Okay, let me hit that on 31428. Localhost 31428. Okay, yeah, this is the one, but it asks for the token. You can generate a first service token. Actually, it's like a Admin password, you need to have the service token to authenticate, to connect to it. It is giving you a clue. You can generate a service token with this command. So, token service account. Create some token. So let's go here. This is like for authentication purpose. Service accounts. Service account will give you authentication to the cluster. Now you have to give permissions to the service account. We are not using the namespace. So let me remove this namespace. Giving this particular service account role as a cluster admin role. We don't need this actually. Okay, some admin role also created. Now, actually it will create a token in the form of secret at the backend. So we can get that. Get the token or the secret in the decoded format. Again, remove the namespace. -n. It should display as the token actually. This command is not working. So once it displays the token, we would use that token, as secret as a login, and we'll proceed. Okay, let me check the documentation. We created, this is what we did. We create a service account and the token also created. We were trying to retrieve this token. Maybe let me try this way. Create a token. Service accounts are like, which will help you have authentication to the services. I have created, it as a dashboard. Create token dashboard. Okay, this is the token actually, but this is in the encrypted format, I believe. Let me try. Not getting the decoded value. Echo this to Python. Okay, whatever it is, like you will log into the, we will be logging using that token. Once we log in, you will see the UI where you will see all the deployments, pods, and so on. We'll try this out again, but this is the whole point of how you use Helm charts, right? And we have seen the values chart, right? Where you can customize your deployments. This is one way of using Helm chart. The other way is you can create your own Helm chart. Example, like I told you, right? You might be having multiple microservices. right? You don't need to hard code and create 16 manifest files and so on. Rather, you will create one microservice and you would parameterize it by passing values. That way, that's the way you create your own Helm chart. That's another actual purpose of deploying your microservice applications. We will look into that as well, creating our own Helm chart. Any questions in this part from anyone? Any questions? Are we good? So creating Helm chart, we shall look into in the next class. This is a command to see the images used by the Minikube cluster. You can see this is how you would see the images. We'll use this tomorrow. Why do you need it and all? We'll discuss this tomorrow. All right, then we'll close here and continue tomorrow if you don't have any questions. Thank you all. Good day. See you. Bye, everyone. And by the way, if you want to stop Minikube, simply Minikube stop. And start it tomorrow. Your installations, your deployments, all of them will be still there. Once it is stopped, you could also stop your Docker. Node stopped. Now, if you see kubectl get nodes, see, you won't see anything now. Again, you have to start it to get started. All right, then. Bye, everyone. Thank you.